Stop using loops in your Python code. They're slow, clunky, and honestly, a pain to read. Just look at this mess. It's definitely not clean code. We have a list of banned users here: admin, test user, and bot account. The current user is test user. They're on the list, so they should be blocked. The old way uses this found variable, starting at false and switching to true once we spot a match. This is a classic loop, but it's inefficient. You're manually checking every single item, nesting if statements and break commands. So much can go wrong with this logic. Sure, it works. Access is denied, but this isn't Pythonic. Check this out. This is how the pros do it. Banned list, username, and one simple if statement. If username in banned user print access denied, you get the exact same result as the loop. But it's lightning fast and incredibly clean. The secret sauce is that in keyword. It literally replaces that entire bulky loop with just a single word. Now, you've seen and used in loops before, forcing Python to cycle through every individual name. Does it match? Does it match? It's checking them one by one. Only then does it set a variable and run another if check to decide whether to grant access. But with this method, everything is condensed. You don't need the for loop at all. This one is different. It's not iterating, it's checking for membership. It asks, does this user belong to this list? Are they a member? It's that simple. Professional code relies on this for fast lookups, validation, and smart control flow decisions. It's the ultimate shortcut. Loops are inefficient to run and exhausting to read. Compare that to this elegant one-line check. This is the Python membership operator. Then operator, fast, clean, and powerful. What's the real difference between a list and a set? Let's use membership operators to unlock that. Practical power of lists versus sets in your code. Imagine we have a database. It provides us with a collection of user emails. We have user 1, user 2, and our admin account. Picture a million members, but for this demo, we will stick to 3. We need to find the admin. Does the admin exist within this list? Are they a registered member of this group? We use an operator, a membership tool, to scan the list and locate that admin email. When we run this, we see the output, admin found. But here is the catch: then operator has to scan every entry, starting from the top. It follows a strict order. It checks every single one. It's like asking the first person, are you the one? The answer is no. You ask the second person, are you user 2? Again, the answer is no. Finally, you ask the third, are you the admin? And they say yes. But with a set, the magic happens. We keep the data, but notice the curly braces. We use then operator again, but because it is a set, something changes. We get the results back instantly. How is an instant result even possible? Remember, a list makes you interview every person one by one. A set works differently. It creates a unique digital fingerprint called a hash. That hash identifies the exact storage location. That is where the value lives. By using a hash, Python jumps directly to the right spot. Unlike a list, which must compare 10, then 25, then 3, then 7, and finally the number 42. Exactly, it compares every item until it hits the end. But here, position doesn't matter. Even if it is last, it is fast. The set uses that code to teleport straight to the correct memory location. This is the power of hash-based lookups. Imagine a list with 1 million elements. You would have to check every single one until you found the millionth person. With a set, you simply ask for that member, and Python goes directly to them in a single step. Lists scale linearly, but sets stay lightning fast with constant time. Here's a pro tip for using Python's membership operator. Imagine you are processing a list of orders and need to filter for specific, valid statuses. Then operator is the best tool. Let's iterate through this list together. You can identify the list by these square brackets. Our goal is to verify the current status of every order. If a status is completed or pending, we want to trigger an action. Here, we will simply print a confirmation that the status is valid. Watch what happens when we run this. The output is clean. We see completed pending and completed again. The code successfully matched against our target keywords. At every step of the process. If you are coming from another programming language, you might be tempted to write your loop like this. But checking every individual status using double equals to see if it is completed or if it is pending is incredibly verbose. It's the long way around. That style results in repetitive code that is harder to maintain. With an operator, you never have to repeat your variable name. You only write it once. You can ditch the double equals signs and the or keywords. Python simply checks if the status exists within your set. It is elegant and efficient. Stop using clunky or statements for simple equality checks. This is a game changer for data pipelines, event filtering, and loading systems where precision is key. Master the membership operator today. It is cleaner. It is faster. It is more Pythonic. Level up your code and leave basic checks behind. Ever wondered how to safely extract data from a Python dictionary? You want to avoid the risky patterns seen in this line of code right here. Do you know why this is so dangerous? If not, you absolutely need to watch this. Let's look at this user profile. Imagine this data is streaming in from a JSON file, a database, or an API response. You have it stored in this dictionary format, mapping the name to Alex and the age to 30. But now, you want to display the user's email address. To print the email, your first instinct might be to access it directly. I'll just grab the email, you think. But if that email key is missing, your program is going to crash. This is where we unlock the power of Python logic. Then operator is the essential membership operator in Python. It essentially asks, are you on the guest list? Does this entry exist? Is there actually an email? In this case, if the email exists, the program will print it out. If it doesn't, we can trigger a backup plan, like staying silent or showing an email missing alert. Running this now, you'll see there is no email in the data. By using the membership operator as a shield, you gracefully bypass that error-prone line of code. Let me show you the alternative. If we remove the not keyword and try to force it, you hit a key error. The system checks for the email, realizes it's not there, and then boom. A key error stops your application in its tracks. You simply cannot access a key that doesn't exist in the dictionary. I'll add the not keyword back to restore our safety net. That is the hidden danger of direct dictionary access. So, how does this work under the hood? When you use the an operator on a dictionary identified here. By these curly braces, Python behaves very intelligently. By default, it automatically scans the keys of the dictionary. When checking membership, it doesn't look at the values, it only searches for the keys. If the key exists, it confirms it's safe to run the code and print that email address. Let's prove this by adding an email. We'll give Alex an old school address, alex@aol.com. A classic choice. Does anyone still use AOL? Well, Alex does. And now that the data is actually present, watch what happens when we run it. The email prints perfectly. And that is how you master safe dictionary access in Python. How can we stop duplicate processing? We'll combine sets with Python's an operator. The an operator is a membership tool. Think of it like checking a guest list. At your local football or cricket club, are you a member or are you not? It works for any group, even a snooker club if you consider snooker a sport. In this code, our processed requests variable is a set. Sets only store unique items. This makes them incredibly fast for looking up specific records. If we receive request ID ABC1-2-3, the first step is to check if it's been handled. We want to know, has this specific ID been processed already? If it has, we simply skip it. We don't want to repeat the work. But if it's new, we trigger an external API call to handle the data. That might mean saving a record to a database or sending info across the web. Once that's finished, we mark that request ID as seen in our set. Running this now, you'll see the API is called because the record is new. But watch what happens if we run the same code again. Since the variable is in memory, the record is already there. If we try to process the same value, nothing happens. No double work, the logic is working perfectly. The output is blank because our if statement only handles the true condition. Let's make it clear. I'll add an else block here to show exactly when a duplicate is detected. By adding this else print statement, we can see the duplicate check in action. Now it logs duplicate request. This ensures you never double say to a database or waste API credits. This same logic applies to real-time data streams. Check this out. Imagine we have a list of records streaming in as dictionaries. We want to process them, but the stream is messy. It contains several repeated entries. Look closely. ID number 1 appears multiple times. ID number 2 is also a duplicate. We need to filter these out. By using our scene ID set, we process each unique record exactly once. We skip the noise. Notice the console output. It processes ID 1 and 2, then immediately skips their duplicates. Our set keeps track of every identifier we've already seen. It handles ID 3 and ignores the final repeat. By using not in with a set, you're performing a high-speed membership check. This is one of the most efficient ways to manage data integrity in Python. It's clean, it's fast, and it protects your external services. Just check the ID. If it's already been handled, your code moves on. This is a high-performance pattern every Python developer should know. Master these membership operators, and you'll write much smarter, faster code. Simple yet powerful. The membership operator works perfectly with strings too. That is because strings are what we call iterable. Essentially, this means you can loop through a string, character by character, whenever you need to. Let's use an operator to check if this message contains an error. This is a very common technique used in system log messages. If we need to detect an issue and instantly alert the admin via SMS, or perhaps a WhatsApp message or an automated call, we simply scan the log for errors to trigger that alert. Let's wrap this in a print statement for our demo. As you can see, the alert is triggered. Now here's the catch. Different developers might code using lowercase, uppercase, or even mixed casing. By changing this word to uppercase, you will notice that our alert no longer fires. This happens because Python is strictly case sensitive. If the casing doesn't match exactly, Python won't find it. To fix this, we need to normalize everything to lowercase. We'll convert the message and then run our print statement again. Notice how the alert is currently not triggering. If you are looking for a specific error, the best practice is to normalize both values. By converting both the log and the search term into lowercase, your code becomes bulletproof. It will match the word error, regardless of how the original text was capitalized. We can even have messy, mixed case text like this, and you will see that the alert still triggers perfectly. It works even with typos or all caps messages. This is a built-in function we call on the string itself. Since it is a string type, you have direct access to the .lower method. The membership operator is incredibly versatile, making it a powerful tool for smart text pattern checks. New to Python? If you don't know this, you're seriously missing out. They are fundamental to the language. Check out this variable called tasks. Inside these square brackets, I have a few specific items: email, code, and review. This is my digital to-do list. I need to email someone, write some fresh code, and then review a teammate's work. It functions just like a task manager. You can even think of it as a simple shopping list. If you're at the store grabbing eggs, bread, and milk, you'll notice they are all separated by commas. Every item is distinct, and we wrap them in quotation marks. Because each one is a string data type, you can't just leave them plain like this. That would trigger an error, as Python would look for a variable instead of a text string. Always use those square brackets. Without them, you'll hit an error because it's no longer a list. It actually becomes a tuple, and you can see that just by hovering over the code in your editor. We want a list for this demo. When you hover over the variable name, you'll see it's a list type. This allows us to access items using their index starting at position 0. The first item is always 0. Then we have position 1, which is code, and position 2, which is our review task. So, while you might count 1, 2, 3, Python counts 0, 1, 2. It's a zero-index system. Think of it as starting from ground zero. It's a crucial rule to remember. Now, check this out. By accessing this element here, we're grabbing the third item. That's how we get email and review. Now, negative numbers might look a bit confusing at first. The minus sign actually tells Python to grab items from the end, while 0 is the very first element. Using -1 means you're starting from the very back of the list. It's the easiest way to get the last item without knowing the list length. If you use -2, you'll jump backwards to the code task. And -3 brings us all the way back to the start. Of course, if you use an invalid index like -4, the program will crash because that item doesn't exist. The same logic applies forward. If you try to call index 3, remember we only have 0, 1, and 2. Since there is no fourth item, you'll get an error. So our highest index here is 2. Just keep these positive and negative indexing tricks in your coding toolkit. Python lists are incredibly versatile, offering indexing techniques you won't find in most other languages. They're designed for high-level efficiency. In Python, performing complex data processing is surprisingly simple and powerful. This is perfect for building robust data pipelines. Imagine you have this dataset right here. Standard indexing lets you target one specific element. To grab the very first item, you'd simply use index 0. But Python lets you slice lists to instantly capture entire segments. Let's run the code and see this in action. 1 to 4. Check out this syntax. Usually, you'd only see one value inside the brackets, just a single position like 0. That gives you one output, the number 10. But by adding a colon, you unlock the power of range. Put your start point before the colon and your end point after. If we start at position 1, we're targeting the second item. Since Python starts at 0, index 1 is our next value. We'll go up to position 4. This covers indices 0, 1, 2, and 3. Notice the fourth position itself is actually excluded from the printout. The logic is simple. The start is included, but the end is not. That first number is where your slice begins. It's your entry point, but the slice stops exactly one step before the final index. Leaving the start blank tells Python to begin at the very beginning. That's why it captures 10, 20, and 30. You can also omit the ending position. Let's start from index 2. From index 0 and 1, we land right on 30. It grabs 30 and goes all the way to 50. Your output looks exactly like this. Want to get fancy? Use -1. This targets everything up to the final element. And because the end is exclusive, that last item is left out. Remember, the ending position is never included. To exclude the last two, simply use -2. It's a clean, efficient way to filter your data. Slicing and dicing with Python is that simple. Just master the colon syntax and you're ready. Get ready to supercharge your Python skills with this essential guide. Whether you are new to lists or just need a refresher, stay tuned. A Python list is like a dynamic shopping list. Here, we are storing colors, red, blue, and green, if we need to swap blue for something else. Python allows you to mutate or change those list items instantly. We will target position 1. Remember, Python is 0 indexed. So red is 0 and blue is 1. We are swapping blue for yellow. Once we run this, you will see blue has successfully become yellow. Just like that, we have replaced a list item. Now, let's look at something even more powerful. Imagine we have an empty list designed to capture application logs. We want to track exactly what the user is doing. A user logs in and then clicks a button. We need to save these events. We want to add both of these interactions to our list automatically. By using the append method, we can push new data into the list. Now our list clearly shows those two user actions. It is a clean and efficient way to handle real-time data. Lists are not limited to text, they handle numbers just as easily. Take this numbers variable, currently holding 1, 2, and 3. 1, 2, and 3. The extend method is a fantastic tool that appends multiple items to the end of your list all at once. This grows your existing list. Notice how we now have 4, 5, and 6. Our list is expanding perfectly. But what if we need to change an item at a very specific spot? Let's analyze the sequence. At position 3, I want to replace that 4 with 99. By using the insert method, we can target that exact coordinate. Running this, you can see our list now features 99 at position 3. The insert method gives you total control over where data is placed. It is precise and highly effective. Earlier, we updated items using direct indexing, but as you can see, the insert method is another powerful way to achieve your goals. And there you have it. Python lists are incredibly flexible. You can mutate and shape your data exactly how you need it.